Hello everyone. In this lab, we write a program to. In this lab, we will continue from the previous lab. In the previous lab, we wrote a program to read the bag of words dataset from the UCI repository. And in today, we are going to do some further work. So in this lab, we will execute brute force computation to compute all pairs similarity with Jaccard and save the result into file. So first we do pre-processing of the input file. In order to look up words for each dog in constant time, I create a map of doc ID has key and set of word IDs has value. In order to make it easy for indexes documents, I am going to subtract 1 from doc IDs and word IDs so that they start from 0. Okay, so our data frame looks like this. So where the first numbers in this array is they belong to doc ID, and the second number is word ID, and the third number is the frequency. So we are not interested in the frequency, so we will get rid of the frequency. So what we're doing over here is we are trying to create a set. So it will be a nested set. So first, where the first value will be the doc ID -1, and the second list of values will be uh, will be word IDs -1. These middle numbers -1. So so first we let words per dog equal empty curly braces. So here we are doing this. Words per dog will be a map of dog ID has key uh, and value has list of word IDs. For dog in dog data passed, so if for dog in dog data passed, for that is for each of these rows in dog data passed data frame, we start from 0 to make it easy to index and loop. So let doc ID equal doc 0 -1. So it will be the first value -1. And word ID equal to doc1 -1. Second number -1. If doc ID in words per dog, so if doc ID is in words per dog, then words per dog, the doc ID dot add word ID. Else, words per dog, the doc ID equal word ID, and that is in curly braces. So it's going to produce something like this. So the words per dog, so the first number is 0, and the child numbers are all this list of values inside the curly braces. And for 1, you can see we have the second list of values 231, 462, 688, and so on. Now we need NumPy. So first I will show you some of the working. So NumPy dot once in the open bracket and then the open square bracket number of dogs comma number of dogs close bracket, that creates a matrix of size number of dogs by number of dogs, and the values are 1. So in this command, we are calculating Jaccard similarity for 2 given document IDs. So here we write a definition for calculating Jaccard similarity. So calculate Jaccard similarity, open bracket, we need a doc ID 1, comma, doc ID 2, and comma, words per doc. So the words per doc is the set of numbers over here, the doc ID and then the word IDs. And doc ID 1 and doc ID 2 is in the range of number of dogs. So what happens is that for each of these values over here, that will be doc ID 1 for rows and doc ID 2 for the columns. We will we will calculate the Jaccard similarity. So this is how we do that. Let doc1 underscore I words equal words per doc bracket doc ID 1. So for example, if the doc ID is 0, if 0 row and 0 column, then words per doc 0 will be all these values here, all this set of values over here. And words per doc ID 2, if, for example, if it is 1, 0, 1, so we are finding the value for 0, 1, then words per doc 1 will be all these values over here. We want 1. Here, this set of values. Then we calculate the intersection and union of word sets. So common words equal doc1 words dot intersection close open bracket doc2 words and close bracket, union words equal doc1 words dot union of doc2 IDs. So the retain is the length of common words divided by length of union words. And that value we will put in here, 0 row and fetched column. So sorry, 0, 1, so fetched row and second column. So now we write a second definition. So calculate, in the second definition, we are calculating number of doc by number of doc matrix with value at ij, denoting the Jaccard similarity between I and j. So definition, calculate Jaccard similarity matrix of the input is words per doc, comma, number of docs. So words per doc is the set of values, this set that we created, and number of docs is the value that we had in the from the fetched lab, the number of documents that was already given in the file. So if I insert a new cell above, I can show you number of docs is 3430. So there are 3430 documents. Let Jaccard similarity matrix equal NP dot NP is for numpy dot ones open bracket and open square bracket number of docs comma number of docs. So this will create the matrix of dimension square matrix of dimension number of docs, and number of docs is 3430. Then we fill the matrix with Jaccard similarity values for doc ID 1 in range number of docs. So range number of docs will be from 0 to 3429. And for each of those values, we will have for doc ID 2 in range doc ID 1 to number of docs. So if doc ID 1 is 0, then doc ID 2 will be in the range from 0 to 3430. Then store the Jaccard similarity value in the matrix. So Jaccard similarity matrix, so 0, say 0, 1 equal, calculate Jaccard similarity matrix, 0, 1, and words per doc. And then what will it do? It will call this the other function, calculate Jaccard similarity. Remember 0, 1, and then words per doc, and this will calculate the value. And then that will be put in place of doc ID 1 in place of 0, 1 in the matrix. And Jaccard similarity matrix of 1, 0 will be Jaccard similarity matrix 0, 1. Now it's a transpose matrix. So it's a symmetrical matrix. So, and then this function returns Jaccard similarity matrix. Then we calculate Jaccard similarity using brute force, and we measure the time taken. So to measure the time taken, we import time. Let start time equal time dot time, open and close bracket, Jaccard similarity matrix equal calculate Jaccard similarity matrix, open bracket, words per doc, number of docs. So it calls this function here, and this function will call this function. So yeah, and then we print. So we want to print time taken to calculate all Jaccard pair similarities, and Kelly braces how many seconds. So that in the Kelly braces with 0 will be replaced by this time dot time, open and close bracket, minus start time. So time dot time is the final time, and start time is the initial time that was measured. So time taken to calculate all Jaccard pair similarity is 58.75 and so on seconds, almost 1 minute. Display matrix. So Jaccard similarity matrix, as you can see that in the diagonal there are all ones, and then all the other values are transpose of each other. So matrix, this is a symmetrical matrix, and we save Jaccard similarity matrix to our file. So will use numpy np.savetxt, open bracket, Jaccard brute force dot text, that's the name of the file, comma, and we want to save Jaccard similarity matrix. Then we calculate average Jaccard similarity of all pairs identical except identical pairs. So take matrix sum and we ignore the identical pairs. So that will be subtracting the ones in the diagonal. So first we do numpy.sum of Jaccard similarity matrix, and then we subtract the number of docs, that is the number of ones in the diagonal, and we divide by the total number of values in the matrix, and that will be number of docs times number of docs. And we subtract the number of docs because that we want to take out the diagonal, and that will be 0.0335 and so on.